Helps if I share the slideshow screen. There we go. Okay. So this is a little bit of, they like to repeat a lot of things so that you remember them. So different protocols here. So there's TCP/IP, and this is a suite of protocols that includes the IPv4 and 6 that we talked about, UDP, ARP, and there's a bunch of others that go in there. TCP/IP protocols, they add a header to the data inherited from the layer above it. Remember that OSI layer thing? They add a header to the data inherited from the layer above it. So layers 7, 6, and 5, data and instruction, known as payloads, are generated by applications running on source hosts. Layer 4, that's your transport layer, usually your TCP or UDP, adds a header to the payload and includes a port number to identify the receiving app. Now, do you guys remember the difference between TCP or UDP? Anyone?
TCP secure.
Oh, there's two of you. Go ahead.
Go for it.
TCP guarantees transmission, whereas UDP doesn't.
Right. So, well, it's not so much transmission as receipt. They, I kind of think of it as TCP looks for where it's supposed to be going when UDP doesn't, is kind of how I remember it. Layer 3, the network layer, it adds its own header and it becomes a packet. The packet is passed to the data link layer on your NIC, which is your network card, which encapsulates data with its own header and trailer, and then that creates a frame. Then layer 1, which is your physical layer on the NIC, receives the frame and places the transmission on the network. Okay, so again, I would go in and hit your PowerPoints to steal some of these graphics because they have some really good ones on the TCP/IP protocols here. So here's your browser. It's dropping a payload, adds a header payload, and it shows how everything connects that I was just talking about. So you have your header payload, header payload, and you can see how everything kind of gets added and then surrounds it all the way down to the frame and then goes to the physical layer. And then there's the browser comes down in, and then it goes the opposite way for the web server. Does that make sense? Any questions on that? Okay. I was going to say, I think that one's one that we've gone through a couple times. So the receiving host decapsulates the message at each layer in reverse order. And the reason they have the order on there is you just have to remember each down and then up. Everything goes in either order or reverse order, and presents the payload to the receiving applications. In transit, transmission might pass through a number of connectivity devices. Connectivity devices are specialized devices that allow two or more network or multiple parts of one network to connect and exchange data, and they're known by the highest OS layer they read and process. So that's how they list them, as by what the highest layer is they read and process. Okay, transmission protocol. Sorry, transmission control protocol. So TCP operates in the transport layer of the OSI model. The three characteristics: connection-oriented, sequencing and checksums, and flow controls. So connection-oriented, TCP ensures that a connection or session is established by using a three-step process. Remember this, called a three-way handshake. I can guarantee you're going to see that on a bunch of different exams. Sequencing and checksums, TCP sends a character string called a checksum that is checked by the destination host along with a sequence number for each segment. Flow control gauges the rate of transmission based on how quickly recipient can accept your data. Okay, so this is just showing source, destination, sequence number, acknowledgement, and then it's just going through how everything looks. on a TCP segment. And this is your three-way handshake. Remember this because I've seen this on multiple certification exams where I didn't think I was going to see it, but I forever will remember the three-way handshake in my nightmares. So remember this one. So the TCP three-way handshake establishes a session before TCP transmits actual data. So 3 transmissions are sent before data transmission. Step 1, request for connection, that's the SYN. Step 2, respond to the request, SYN or an ACK, ACK is acknowledge. And then step 3, a connection is established, and that's ACK. So remember SYN, SYN ACK, ACK. That's your 3 steps. Yeah, exactly. Surplus. Mine I saw on the Certified Ethical Hacker, and I believe it was also on the Computer Hacking Forensic Investigator one too. I don't know.
SYN stand for?
You had to ask. I cannot remember. Hold on one second. Oh, did someone? It's one of those ones that I cannot remember for the life of me. Synchronize. Don't know why that one's so hard for me to remember, but SYN is for synchronize.
Thank you.
Nope, no problem. Okay, so synchronize, acknowledge, and then acknowledge. I just remember SYN, ACK, ACK, because it sounds weird, and that clicked for me. So after the 3 initial messages, the payload or data is sent. Sequence numbers will be increased by the number of bits included in each received segment, confirms the correct length of message was received. So these are the flags that it's showing. There's your sequence, ACK number, flag, SYN. And then on the way back, here's your ACK, SYN, ACK, that one. And then here's your ACK. Okay. Any questions on three-way handshake other than what does SYN stand for? Sorry.
How do they shake hands if they're computers?
Very carefully. So UDP is unreliable connectionless protocol. So I don't know why they put a D in there, honestly, but no three-way handshake is performed. UDP does not guarantee delivery of data. UDP provides no error checking, sequencing, or flow control. This makes it's more efficient, so it's way, way, way faster, but that's comes at a cost for other things because it doesn't check for the other stuff. So if you don't need that stuff checked, it's great. So you can use it for live audio or video transmissions. You can also use it for carrying messages that fit within one data packet. UDP header contains only 4 fields: source port, destination port, length, and checksum. The use of a checksum field is optional in IPv4, but it is required in 6. Okay, IP operates at the network layer of the OSI model. It specifies where data should be delivered, identifies the data source and destination IP addresses. IP enables TCP/IP to internetwork, to traverse more than one LAN segment and more than one type of network through a router. IP is an unreliable connectionless protocol. That means that IP does not guarantee delivery of data and no session is established before data is transmitted. IP depends on TCP to ensure messages are put back together in the right order and to ensure each message reaches the correct application on the receiving host. So this is your IPv4 packet example, and this is an example of an IPv4 header, just for your information. IPv6 packets. They use a different packet format than 4. They can accommodate a longer IP address because, as you know, the IPv6 addresses are significantly longer. There is no fragment offset field. The IPv6 hosts adjust their packet size to fit the requirements of the network before sending messages. Okay, ICMP is a core network layer protocol that reports on the success or failure of data delivery. This can indicate the following: when a part of a network is congested, when data fails to reach its destination, and when data has been discarded because the allotted TTL has expired. ICMP announces transmission failures to the sender, but does not correct the errors it detects. It provides critical information for troubleshooting network problems, which is usually why a lot of those are used. ICMP v6 on an IPv6 network performs the functions of ICMP, ARP, and IPv4 networks. Hey, don't fight over the top of each other right next to me. ARP, and before I hit ARP, any questions? No, okay. ARP works in conjunction with IPv4 to discover MAC addresses of a host or node on the local network, and to maintain a database that maps IP addresses to MAC addresses on the local network. So ARP is a layer 2 protocol that uses IP in layer 3 and relies on broadcasting. It operates only within its local network. ARP table is the database of the IP to MAC address mappings. An ARP table can contain 2 types of entries: dynamic or static. This is kind of like the difference between dynamic or static TCP IP addresses or IP addresses. Created when a dynamic is created when a client makes an ARP request that could not be satisfied by data already in the ARP table. Static are those someone entered manually using the ARP utility command. To view, sorry, I gotta move. To view Windows Workstation ARP table, there's a command there, the ARP --A. And then this is an example of what the ARP --A would show. And as you can see on the left, there's your IP, and then there's your MAC. And then on the far right, you'll see static or dynamic. Neighbor discovery protocols. Okay. IPv6 devices learn about other devices on their network through a process called neighbor discovery, or NDP, neighbor discovery protocol. This information carried in ICMP v6 messages automatically detects neighboring devices and automatically adjusts when nodes fail or are removed. So it offers several message types: RA, which is router advertisement; RS, router solicitation; redirect; NS, neighbor solicitation; NA, neighbor advertisement. Any questions? Okay. Ethernet is the most important data link layer standard. It's capable of running on a variety of network media. Ethernet offers excellent throughput at a reasonable cost. It's the most popular network technology used on modern LANs. Ethernet 2 is the current standard. Ethernet adds both a header and a trailer to the payload. It creates a frame around the payload. The header and the FCS make up an 18-byte frame around the data. The data portion of an Ethernet frame may contain from 46 to 1500 bytes. MTU, or maximum transmission unit, is the largest size that routers in a message's path will allow at the network layer. So here's you an example of an Ethernet 2 frame. Your SFD, destination address, source address. This is your type of Ethernet, data plus padding, and then your FCS. Okay, Which protocol's header includes the source MAC address? Do you guys remember? Ethernet, UDP, IP, or TCP? ABCD. Got one person. Okay, we're kind of split. So let's see. Ethernet. All right. Ethernet encapsulates data with the header and trailer and creates a frame, and the frame includes your MAC address. Encryption protocols use a mathematical code called a cipher to scramble data into a format that can be read only by reversing the cipher. Now, before I go on, if you're interested at all in this, there is an entire field dedicated to encryption protocols and ciphers. And if you are at all into this, it is a field that needs people in it. So keep that in mind. The purpose of encryption is to keep information private. Encryption methods are primarily evaluated by 3 benchmarks: confidentiality, integrity, and availability. Now, you guys, I don't know if you've heard these 3, but these are called the CIA triad, and it is a security standard model that you should know and you will see running through a lot of things. So they call them the triad, and you just think of them in a triangle. Yeah, yeah. This is the first time I heard it, I was like, huh? But there is also an inverse triad for CIA, which is basically how to do all the things wrong, which is called DAD, which we can go over sometime too, if they don't. And they don't. Okay, so have you guys run into the confidentiality, integrity, and availability? Have you run into this before? Anyone? Nope. Okay, so there are 3 key ingredients basically in cybersecurity that you have to balance with each other. So your confidentiality, that means keeping your records or client names or anything like that confidential. Your integrity, that means making sure that whatever data or even hardware that you are responsible for has been maintained in a way that you know that it's good. So, you know, it's got good integrity. And availability, you know, when you have those DDoS attacks and they knock everything offline, that affects your availability. So availability and the amount of uptime are also integral to making sure that you have good security. Yep, response time, exactly. So those 3 are benchmarks that you use in cybersecurity to, sometimes you have to have more confidentiality depending on the business, or more integrity, or more availability. You know, you just kind of have to balance between the 3 of them, but you should have all 3 of those, and you should balance between them for whatever it is that you're working with. Key encryption. Okay, a key is a random string of characters woven into the original data's bits. It generates a unique data block called ciphertext. This key is created according to a specific set of rules or algorithms. Key encryption can be separated into 2 categories: private key encryption or public key encryption. Okay. So this is an example of private key, and then the one on the bottom is public key. I highly suggest you keep that. I would go in and just either save that slide, or I would go in and do a snip of this slide, because this is a really good graphic that explains the difference between private key and public key encryption, and you'll see those in a lot of exams. Hold on one second here. Sorry, I have someone at the door. Give me 1 second. Okay, sorry about that. Okay. So this is probably one of the better graphics I've seen explaining that. So I would make sure that you memorize this particular setup. Okay. Yep. Public decrypts with public key. That's a good way to remember it too. All right, so IPsec, or Internet Protocol Security, is an encryption protocol suite that defines rules for encryption, authentication, and key management for TCP/IP transmissions. Well, one of my cats just decided to knock everything over. So it has 5 steps: initiation, key management, security negotiations, data transfer, and termination. And it operates in 2 modes: transport mode or tunnel mode. Yeah, that's exactly what happened. There was a box that was, about this far over the edge, and they decided rather than stand on the box, that portion that was sturdy, they'd stand on the edge and went off the edge. Transport mode and tunnel mode. So these are just super, super quick runovers of what these mean, and we will have more of them later too. Secure socket layer, SSL, and TLS, or transport layer security. Both SSL and TLS are methods of encrypting TCP/IP transmissions. Both protocols work side by side and are widely known as SSL TLS or TLS SSL. When a client and server establish a SSL TLS connection, they establish a unique session, which is an association between the client and server. The session is defined by an agreement on a specific set of encryption techniques. A session is created by an SSL handshake protocol. The handshake protocol allows the client and server to authenticate. It's similar to the 3-way handshake. Okay, remote access protocols. Remote access is a service that allows a client to connect with and log onto a server, LAN, or WAN in a different geographical location. Remote access requires a type of RAS, or remote access server. There are 2 types of remote access servers: dedicated devices or software running on a server. A lot of them have shifted to the secondary now, but it just depends on what environment you're in. Types of remote access include remote file access, terminal emulation, also called remote virtual computing, or a VPN, which is a virtual private network. Remote file access. So FTP is file transfer protocol, and this provides remote file access. There are 3 related technologies included in the following, which is FTPS, which is FTP secure, or FTP over SSL. And this offers an added layer of protection for FTP using SSL or TLS. The reason that you want these is because otherwise your passwords are in plain text with file transfer protocol. SFTP, which is secure file transfer protocol, is file transfer version SSH that includes encryption and authentication for transferring files. And then there's TFTP, which is trivial FTP, and it's a simple protocol similar to FTP, except that it includes no authentication or security for transferring files. Terminal emulation. Okay. Probably a lot of us have worked on or with something like this at some point. So a terminal emulator is software that allows a user on one computer or client to control another computer, host, or server. So examples of command line software Telnet and SSH, yeah, they decided to take them off. Hold on one second. Okay, sorry about that. Some help moving some of the cat catastrophe. So terminal emulation. So there's command line, Telnet or SSH. Telnet is really quite old. I first saw that in '98. So examples of GUI-based software are Remote Desktop for Windows, or RDP, sometimes you'll see it called, Join.me, VNC, and TeamViewer. A lot of times if you call in to any place, yeah, ZenMap is another, well, ZenMap's a GUI for Nmap. So Telnet is your terminal emulation utility that allows administrator or other users to control a computer remotely. This one has very little security for establishing a connection, and it provides no security for transmitting data. That's why you should not see that. I say should not because you never know. SSH, Secure Shell, is a collection of protocols that provides for secure authentication and encryption, guards against a number of security threats, unauthorized access to a host, IP spoofing, interception of data in transit, DNS spoofing. Secure connection requires SSH running on both client and server, and allows for password authentication using public and private key generation. So this is PuTTY, and this is an app that you can use to configure on Windows for an SSH connection. I've seen this for all sorts of different things, and you will probably run into PuTTY at some point in time. Yeah. Oh, what's an update? Yeah. If they have Telnet, you're probably going to hear what's an update. So good point. RDP, this is Microsoft proprietary protocol used to connect and control a remote computer. VNC, that's your virtual network computing. This one uses cross-platform protocol, RFB, remote frame buffer, to remotely control a workstation on a server. VNC is open source, so many companies develop their own software that can run OSs on client computers, remotely access computer tablets and smartphones, remotely control media equipment and surveillance systems. Out-of-band management relies on dedicated connection between the network administrator's computer and each network device. A remote management card is attached to the network device's console port. A single device, such as a console server or console router, provides centralized management of all linked devices. Okay. VPNs. I'm hoping that you guys have all heard of VPNs. A VPN is a network connection encrypted from end to end. Remember that, end to end, that creates a private connection to a remote network, sometimes referred to as a tunnel. VPN can be classified according to three models: site-to-site VPN, client-to-site VPN, which is also called host-to-site VPN, or remote access VPN, or host-to-host VPN. To ensure VPNs can carry all types of data securely, special VPN protocols encapsulate high-level protocols in a process known as tunneling. Many VPN tunneling protocols operate at the data link layer to encapsulate the VPN frame into a network layer packet. Some VPN tunneling protocols work at layer 3, which enables additional features and options. Most tunneling protocols rely on an additional encryption protocol to provide data security. And then there's some common protocols there. LTP or layer 2 tunneling, GREE, generic routing encapsulation, OpenVPN, and then IKE version 2. This is a VPN frame, and it just shows how your IP address is put in there. Cisco developed a Cisco developed a proprietary protocol called MGRE, or multi-point GRE, that allows the configuration of multiple tunnel destinations on a single interface. A type of enterprise VPN using Cisco devices called DMVPN, or dynamic multi-point VPN. DMVPN dynamically creates VPN tunnels between branch locations as needed, rather than requiring constant static tunnels for site-to-site connections. Yeah, Signal uses end-to-end encryption to encapsulate. So Signal, what it does is your messages, it has a check, has your 2 check marks. If you ever use the app, you'll see the 2 check marks. The first check mark is making sure that your end is secure and encrypted. And then the second check mark is the other end, and that makes your tunnel, which is encapsulated with. I'm not sure what algorithm or anything it uses, but I will say that if you're going to be using one, Signal is better than, I can't remember the other one, Whisper something, which is actually owned by Facebook. So I don't think that's particularly secure anymore, because Facebook is not known for keeping things secure. Yeah, Signal is the one that I have seen that's got the best security so far. I've used it. I have a friend that lives in Scotland, and cross texting for that is just an absolute pain. So we use Signal to chat back and forth, and it's worked really well. So I'd highly recommend it if you're going to be using that kind of app for something, just for security. Yeah, Signal. And that's another thing. If you're going to be overseas, there are certain apps that when you get overseas, they have different versions and they're blocked because they have a lot of censorship issues in those particular countries. But Signal is one that, because of the way that it's encrypted, and it's been pretty successful in being used for encrypted chatting. Okay, remote access policies. Common requirements of a good remote access policy. Remote access devices must be up to date with patches, anti-malware software, and a firewall. Device access must be controlled by a strong password or biometric measures. Passwords must be strong and must be changed periodically. The device's internal and external storage devices must be encrypted. Company and customer data must be kept secure. The loss or theft of any devices used for remote access must be reported immediately. Encrypted VPN software must be used to remotely access company network resources. While remotely connected to the company network, the device must not be connected to the open internet or any other network not fully owned or controlled by the employee. So no hooking up to McDonald's while trying to find state secret work. Remote sessions must be terminated when not in use. This is one of those, this is something we would absolutely love to see all of these points being followed, but I can guarantee they will not be. Unless you're working somewhere with a security clearance, and they have to be or you get fired. But a lot of places, the top one there is the worst, most forgotten or neglected portion of any sort of device, whether it's owned by the company or not.
Even when working somewhere with that requires security clearance, there's always going to be someone that's going to test those.
Yeah, that's true. You're always going to find somebody out there that's like, you don't really mean that, do you? All right, so looks like the next section is troubleshooting network issues. So NetStat. This displays your TCP/IP statistics and details about TCP/IP components, connections on a host. This is information that can be obtained from, or information that can be obtained from it includes port on which the TCP/IP service is running, which network connections are currently established for a client, how many messages have been handled by an interface since it was activated, how many data errors have occurred on a particular network interface, tracer or trace route, those are used tons. NetStat is too, but I'd say the second one is the one I saw used the most, at least for what I did. Windows Tracer utility uses ICMP echo requests to trace the path from one network node to another, identifying all intermediate hops between the nodes. Linux, Unix, and OS X systems use the traceroute utility to send UDP messages to a random port on a destination node. It's basically the same concept. So this shows the traceroute utility. It sends out and gets the different error messages that you see back for information. Like this one, it tells you there's your port's unreadable. And the reason that you use these is so that you can trace down where the issues are and then start working on them. TCP dump is one that you will use a lot too. This is a free command line packet sniffer, and it's run on Linux or Unix operating systems. It captures traffic that crosses the computer's network interface. Output can be saved to a file that you can filter or playback, and you can either use the sudo, and that's that one that ups your rights so that you can access the root command. So you can access the root. It's basically like giving admin rights, but in Linux. So you remember that article I showed you where we were talking about TCP dump as the second process? This is it. Solving common network problems. Duplicate MAC addresses. This usually means that there's spoofing. So 2 devices on the same network with the same MAC address is a problem. MAC addresses can be impersonated, which is a security risk called spoofing. It happens most often when managing multiple virtual devices on a large network. Most switches will detect the problem and produce helpful error messages. Then it's a matter of tracking down which virtual devices have the same MAC address and update each device's configuration. And you hope that's all it is, because there are all sorts of programs that you can actually use to create spoofed MAC addresses. So I hope that it's a virtual device that you own that you can fix and not someone else messing around. Hardware failure. So this is the thing that we all fear. When a router, switch, NIC, or other hardware goes down, use tracer or traceroute to track down which one's malfunctioning. And because usually you have so many on a larger network that you know there's a problem, but you're not really sure where to start. To get more accurate trace feedback on questionable router by targeting a node on the other side of that router rather than aiming for the router itself. Use ping to test for network connectivity. And that's when you remember the reply request timed out. That's what they're looking for. Okay, another knowledge check. What protocol must be allowed through a firewall for tracert to work correctly? SSH, NDP, ICMP, TLS. They kind of mentioned this as an aside, so I don't feel bad if you don't remember. Wow. You were paying attention. Good job. So
Everyone
ICMP,
else looked really sure, so I was like, yeah, C.
You're like, C. Yep, so ICMP, Tracer requires ICMP in order to be used. Okay, so these, do you feel comfortable with these here? Do you have any questions about these before we end the lecture for the day?
I had a question.
Okay.
Is YouTube still giving you issues with putting up the classes?
No, I should be able to get a bunch of videos up there tonight. It's going to be a slightly different channel, so you guys will have a new link. I'll give that to you, and you'll at least be able to get some more stuff tonight.
All right, that's good because I missed the last or the on Wednesday, I think, and that was rough.
Yeah. Yeah. And if you ever have any questions, you can always, there's, my office hours, you can always ask me tons of questions. Remember that. So yeah, tonight you should get this video, and you probably just get bombarded with a bunch of other stuff too. So beware, check your Discord channel. And I will probably put the new YouTube channel on an announcement on Blackboard too. So I went ahead and did public on it so you guys can search for it, because I was having problems with the other one. But I think I've got everything happy and copacetic with the YouTube people, and they've given me enough length to get all of our videos out there now. So it takes a little while to encode, so I'll get everything out there. And tonight's might take a little bit longer to get up the video for that one, but when it's up, I'll send you a link for that one too. Any other questions? Okay.